So like I was saying before, today we're going over all of the types of quadrilaterals that you're going to come across and also their properties. Because today what you're going to do after the notes is you're going to apply those properties to solve for angles and side lengths, right? So we need to know the facts about each shape before we can apply them to the shape. Now, over here on the side, I know it's on mine, it's kind of very blurry, but there are 4 different types of parallelograms, right? 4 of our shapes that we're going to discuss today are parallelograms. One, of course, is a parallelogram. Then we have rectangle, square, and rhombus. The last 2 are not parallelograms. Now, what makes a parallelogram a parallelogram?
They have 2 parallel sides.
Perfect. They have 2 pairs of parallel sides. So what we're going to do is you can see there are 4 different categories for the properties that we're going to go over today. There's angle relationships, side relationships, diagonal relationships, and then lastly, a special relationship. So first, we're going to mark up the parallelogram. And yes, we just said that a parallelogram has opposite sides parallel. So we're going to put arrows, because arrows mean what? Parallel. So opposite sides parallel. And also, what are opposite sides in a parallelogram? Yeah, they're congruent. So we're going to put tick marks to show congruence. And all of these properties can be found in the side relationship. See, opposite sides are parallel and congruent. Then, now try not to read the properties. Try to just think. What do we know about the angles in a parallelogram? What do you think we know? Take a guess. Try not to read it. About the angles. What do we know about the angles in a parallelogram? Yes, opposite angles are congruent. So here, this angle is congruent to this angle, and this angle is congruent to this angle. Opposite angles are congruent, meaning they're the same. And that's what it says here. Opposite angles are congruent. My gosh, bless you. Now also, there's something more special that you may not have known. Say this angle down here is angle 2 and this is angle 1. These 2 angles are called consecutive angles, meaning it just means that they're angles right next to each other. So 1 and 2 are angles next to each other, and in a parallelogram, if 2 angles are next to each other, it means that they are supplementary. They add up to 180. Yes, so that's what it says here. Consecutive angles are supplementary. Angle 1 plus angle 2 is 180. And if you don't think you'll remember that, consecutive just means next to. Man, their music is loud. Okay, so now there's one more type of relationship we have to discuss, and that's diagonal relationships. So we're going to go ahead and draw in our diagonals. Now, how do we draw a diagonal? Vertex to vertex across the center of your shape. Now, unlike we did in polygons where we were trying to create triangles, here we can cross diagonals. We can, my gosh, there we go. We can create diagonals that cross. Now, what do you think we know about these diagonals? Right, they're not equal, right? It's clear that this one here is shorter than the other one. Yes. Now, another way to say that is they bisect each other. They cut each other in half. So, we've already used the 1 tick mark and the 2 tick mark. Do you think we can use those again? What if I put a 1 tick mark there? What would that mean?
The other side.
Yeah, it would mean it's the same length as the outside. Well, we don't know that. That's not true. So we have to use how many tick marks? 3. And where else should I put 3?
Same line.
On the same line on the other side. Good. What do I put on the other diagonal, do you think? 4. Good. You're getting it. So that was diagonals bisect each other. Now, shh. Do you remember how I said that a rectangle, a square, and a rhombus are all parallelograms? So what does that mean for those shapes? They all have right, they all have not just parallel sides, they all have think about it. Right. So if you say a rectangle, a square, a rhombus are parallelograms, it means that all 3 of those shapes share the exact same properties as the parallelogram, right? They're all types of parallelograms. So most of this for a rectangle, we're going to write C parallelogram because it has the exact same properties. Except it may have some more properties, making it specifically a rectangle. Now, what do you think specifically makes a rectangle a rectangle? Right. We know, because it's a parallelogram, opposite angles are congruent and consecutive angles are supplementary. But beyond that, we also know that all the angles are the exact same. They're all 90 degrees. So we're going to draw 90-degree symbols, little squares in each one of the corners. What do we know about a rectangle side lengths? Or sides? What do we know? Yes, just like a parallelogram, opposite sides are parallel as well as congruent. Just like a parallelogram. Nothing changed there. And then we're going to draw our diagonals, going from corner to corner, vertex to vertex. Now, not only do they bisect each other like it says in parallelogram, but it also has one more property. What do you think that property is? Looking at these diagonals. Ah, now we know the diagonals are congruent. So we've used 1 tick mark, 2 tick marks. How many are we going to use now? 3. And we're going to put them on every single part. Because not only do they bisect each other, they're also congruent now.
Oh my god. They have so many stitches.
So many stitches. Okay, so now we have a square. Now a square is a type of, it's a quadrilateral one. What else is it? It's a parallelogram and it is a rectangle. Also, yes, and we'll get to that in a second. I heard someone say it already. Yeah, it is a type of rhombus, technically. So, isn't it also a what?
Just kidding. I thought it might have been a diamond.
Oh, no, no, no. Diamond is not a mathematical term. Good. All right. So, for the sides, what do you think we're going to mark here? What is special about a square? Ah, all sides are congruent. So yes, opposite sides are still parallel because it's a parallelogram, but now not only are opposite sides congruent, all sides are congruent. So we're going to put 1 tick mark on each. Yes, it may not have been printed correctly. It is supposed to be a square. And then, what do we know about the angles? Ah, they're all equal. They're all 90-degree angles. This is the property that we brought down from rectangle, right? A rectangles. And then let's draw our diagonals once more. Ugh. Nope, wrong color. Okay, so how do you think we're going to mark up these diagonals? What are we going to do? Right on what? What do we know about these diagonals? They're congruent because it was a property of what? A rectangle, and we know a square is a type of rectangle, so they're all congruent, meaning we can put 2 tick marks on all of our parts. Now a square has something more special about it. Yeah, what angles? So if all the middle angles are the same, what do they have to be? Yes, because you're right, all the middle angles are the same. The only thing they can be, because we know altogether all 4 of those angles have to add up to be 360. Those lines are perpendicular, actually. This is a 90-degree angle right here.
Whoa. Not all the other ones are also 90 degrees.
Which one? Yes, in the center. Yes.
A square instead of square.
It also has one more property that the diagonals do. What do you think? Yeah, I mean, each one creates a triangle. But look specifically, don't draw this, don't do what I'm doing right now. But look here, this light purple triangle. What type of triangle is that?
Isosceles.
Oh my gosh, it's isosceles.
It's isosceles.
So what do we know about an isosceles a triangle? Ah, the angles are equal, right? These angles down here. So what is the diagonal doing to the angles, actually? It's bisecting them, right? Because if that's 90 degrees in the center, and those 2 angles are the same, it means they have to be what? 45s. So 90 divided by 2 is? So the angles are being bisected, yes. And obviously you could have read that over here. Diagonals bisect the angles. There's a lot going on in this picture, so I'm not necessarily going to write that they're being bisected.
So if someone says B there or B square, I'd rather B square.
There's lots of properties of a square, yeah. Okay, now on to rhombus. Is a rhombus a type of rectangle?
No.
Is it a type of rectangle? Did I just say that? A type of square. Is it a type of square? No. Is a rhombus a type of parallelogram?
Yes.
Is a square a type of rhombus?
Yes.
Yes. Is a rectangle a type of rhombus?
No.
No. Good. Okay, so because a rhombus is a type of parallelogram only, for the side measures, all we know is the same properties as parallelogram. I'm sorry, for their angles. So opposite angles are congruent. And also consecutive angles, angles right next to each other, add up to 180. That's all we know about the angles. Now the side lengths, however, what do we know about the side lengths of a rhombus?
The diagonal ones are, the thingy.
Well, I think that you're confusing a rhombus with a parallelogram. What's the difference between just a parallelogram versus a rhombus? What's the difference? What makes a rhombus a rhombus?
Equal sides?
All sides are equal, not just opposite sides. All sides are equal. So we're going to put one tick mark on all the sides. This is why a square is a type of rhombus. Opposite sides are also always parallel.
That's what I was gonna say.
Oh, that's what you were saying? You were saying diagonal.
I didn't know how to explain it.
I'm sorry. All right, so now let's draw in our diagonals. What can I say about the diagonals on a rhombus? Are they congruent? No, they're not congruent, but yes, they are perpendicular.
Like they make like right angles. Like,
In the center,
yeah.
yes. What else do we know? What's true for all parallelograms? The diagonals.
Equal to the bisecting.
Bisect each other, yes. So if this is 2, this is 2. If this is 3, this is 3. And also, just like a square, the diagonals bisect the angles.
But don't these make right angle triangles?
Yes, they do, see?
So,
Now, notice in this rhombus for the diagonals, why does it say C parallelogram and not C square? Because it looks like it has the same properties as a square, right? Diagonals are perpendicular, diagonals bisect the angles. That's the same as square. Why could I not say for that entire box C square? What does a square have for its diagonals that a rhombus does not?
All equal sides. All sides.
All the diagonals are congruent, right? So that's why I couldn't say C square, because square says C rectangle and rectangle says the diagonals are congruent, which is not true for a rhombus. I know this is confusing. All right, so now we're done with parallelograms. Moving on to this shape. What is this shape? Trapezoid. Do we know anything about a trapezoid's angles?
the bottom two and the top third.
So yes, this is a common mistake. When you guys think of trapezoid, your automatic reaction is to think of an isosceles trapezoid. Now, an isosceles trapezoid, don't draw this. An isosceles trapezoid has the sides being congruent and also these angles being congruent. However, this is only one type of trapezoid. In general, a trapezoid does not have to be isosceles. So, in general, do we know anything about the angles? All we know is they add up to 360, which is a property of a quadrilateral, right? All quadrilaterals, the interior angles sum to 360. So we actually can't write anything here for the angles. Yes?
So what about the trapezium or whatever?
Trapezium?
I don't know, what is that?
Trapezoid.
It's just the same thing. Wait. Is it the same thing?
A trapezoid?
No. Wait, I don't know. Oh, it's Oh, so they say trapezoid, for Canadians and Americans, and in British and Great Britain and Australia, they say trapezium, so.
Oh, weird. Huh, trapezium. That's weird. Yes, in in the US we call it trapezoid, I guess. Okay. So, also for the sides, what is the only thing we know about the sides of a trapezoid? All we know is this top and bottom are parallel. And actually, these parallel sides we call the bases. So this is base 1 and base 2. It only has one set of parallel opposite sides. Now, these sides are parallel. Why do we not call this a parallelogram?
Because all the sides aren't parallel.
We don't have two sets of parallel opposite sides, right? If we did, then yes, it'd be a parallelogram, but we don't. We only have one set, so it's a trapezoid.
Aren't the like left and right sides congruent?
So that's what I was saying. That is a type of trapezoid. You're thinking of an isosceles trapezoid.
Okay.
So, for instance, if you just say trapezoid without the initial isosceles, generally it means that you're talking about a shape that could look like this, right? It's clear that those two sides are not congruent. However, a type of trapezoid is the isosceles trapezoid. Oh gosh. Is the isosceles trapezoid, where these sides are congruent and these angles are congruent and these angles are congruent. This is an isosceles trapezoid. It's just a type of trapezoid. So if it says isosceles, then yes, you know the sides are congruent and the angles are congruent. But if it doesn't say isosceles, you do not know. Now there is one more special relationship that we must go over, and it is called a mid-segment. Let's see, what color haven't we used? Blue? A mid-segment goes from the midpoint of one of the legs, this is called a leg, to the midpoint of the other leg. And this line is actually parallel with our bases. And the reason it's special is because this line is actually the average of the bases. So say the top base was 20 inches long and the bottom was 30 inches long. How long is the mid-segment? 25, right? To find average, you take the two numbers, add them together, divide by 2. It's the same thing as this little formula we wrote over here. Base 1 plus base 2 times a half. Okay, we're almost done, and then we'll do a brain break. Now, what is this shape called? A kite. And yes, it literally is called a kite. Now, what makes a kite is it has two sets of consecutive sides congruent. This means that the two congruent sides are next to each other, like this. Two sets of consecutive congruent sides. And also, it has one set of congruent angles. The congruent angles are between the congruent sides. We do not know that this angle is congruent to this angle. We have no idea. Well, darn it. And then the diagonals are perpendicular. And also, the diagonal between the congruent side angles is being bisected. The other diagonal clearly is not being bisected, right? It's not being cut in half. Okay, I think that's it. Are there any questions from this chart?
So the left.
Yeah. Any questions about this chart? It's pretty straightforward, right? The hardest part about this is going to be remembering the properties. Because do you think I'm going to give you this chart on test A?
Yes.
No. So the hardest part is remembering these things. That's okay.